So the topic of today's discussion is asynchronous sequential circuit. So asynchronous means sequential circuit. We know that circuit which work with respect to clock. Okay. So asynchronous means how you can say that this circuit is asynchronous means with respect to what saying. Suppose two domains are there. Okay. So if one domain is working at 40 megahertz, another domain is working at 30 megahertz. So for 30 megahertz domain, that the domain which is working at 40 megahertz is asynchronous. Okay, so we can say we should speak in term of asynchronous, like with respect to what we are saying this is asynchronous. Okay, so the agenda of today's discussion is to understand the asynchronous sequential circuit operation modes, then how to design procedure for asynchronous sequential networks and possible hazards in the asynchronous sequential networks. So we'll see these three topics in today's asynchronous sequential circuits. So coming to asynchronous sequential circuit. So clocked synchronous sequential circuit. A clock creates synchronous event that occur at all the flip-flops. So we know that in our design, suppose if we are saying that our design is synchronous. Okay, synchronous means there is one global signal. So all the events that will occur with respect to clock. Means suppose you take example. So there are 10 flip-flops. Okay, so the common source is clock to all these flip-flops. So whenever clock will come, they will sample the input to the output. Okay, so that is the objective of clock sequence. That is the objective of flip-flops. Like, so whenever clock is coming, whenever when a global event is coming, based on that they are sampling the event. So all the flip-flop state changes are synchronized by the clocking event. So you can say that that global signal is used for synchronizing all the events in the circuit. So input must occur within a certain time before the clock event. So they are telling that when your flip-flop want to sample your input, so that input should come some time before sampling, like your data should be stable minimum time before the active edge of the clock. So that is what they are called as setup time. Output occur within a certain time following a clock event. Okay, so synchronization is required. So they are telling that output occur within a certain time following a clocking event. So after the clocking event, that is the passage of the clock, your input will take some time to process, and after that you will get the output. So we need a synchronization for that. So synchronization simplifies design and allow for the more robust systems. So in synchronous, why you are going for a synchronization means your design is much more robust and controllability is more. Your design is simple, means it is very simple to design the synchronous circuit, because only we know that we have to work with respect to one global signal, that is clock. Okay, so by seeing that clock signal only, there should all the events should occur. Okay, so it is very easy to design synchronous circuits. Now what is the problem with synchronous circuit? Input must be synchronized in a synchronous network. So what they are trying to say, that input must be synchronized in a synchronous network. So like you have to synchronize the input. So you take that, suppose you sampled the input of D flip-flop at the first passage. Okay, so you cannot sample the input of the next. Suppose that two flip-flops are there. So at the first clock passage, you sample the input of the first flip-flop and you will get an output after some time in it. So that data is available to the next flip-flop, but next flip-flop will not sample the data until or unless new passage will next passage will come. So this means that the input is synchronized with the synchronous network. So clock period must be designed for worst case in synchronous network. So what we are trying to do here? So here we are doing